Okay. Sorry about that. Got a telephone call there in the recording. I tell you, that's what happens when you own your own recording studio. You got to sometimes adapt and overcome. So here we go. I'm going to go ahead and do a free body diagram for this one. All right. So we have good old FG. We have good old force normal. We have bad old force friction. And then we have FT1. Okay. Now, one of the things you're going to see here in a minute is there's actually more forces than what I've showed on the diagram. However, they're component forces, and you don't ever draw component forces on a diagram. That's one of the big cardinal no-nos in AP Physics. Okay, Mass 2. Its diagram is, guess what? It's going to look almost the exact same. Okay. I have FG, I have force normal, I have FT2 this time, and then I have FT1, and then I also have friction. Oh man, there's a whole lot of stuff going on that one, but it's not impossible. Okay. And then last but not least over here we have a little bit of room. Do old lowly Mass 3 with its measly 2 forces. Get that weak stuff out of here. FG3. Oh, I don't call that FG2, and then call that one FG1. Oh, time for calisthenics again, folks. All right. Got the blood pumping and ready to get back to it. All right, let's see. FG3, and then I'll just call this one FT2. Okay, so here's what we're going to do. We're going to do the exact same thing we've already done before. We're going to do Newton's second law statements. Okay, so I'm going to do my system-wide one first. Mass of the system times acceleration of the system. And since we're going to assume this thing is in motion and it is accelerating, it's not going to be equal to 0. Okay. Sum of the force on number 1, sum of the force on number 2, and then the sum of the force on number 3. Go ahead and get them all done right now. Equals, mass 1, mass 2, mass 3, acceleration of the system, acceleration of the system, acceleration of the system. Equals. Okay. Now, mass 1. All right. In class, we talked about how there is a missing force that needs to be considered that is not on the diagram. And what it is, it's the component force of Fg. Okay, so bear with me for a second. I'm going to take this diagram and kind of turn it sideways so we can actually look at it like this. Okay, now we know that that force and that force are kind of similar. The force normal, I think I like to call that one the shadow force of force normal. It's not really the force normal, it's like the opposite. And then you have this little force right here that actually does affect this. And it affects this because this is the component of gravity that's wanting to pull that box downhill. It is not one you put on the diagram. So actually what I just did there, you would never, ever want to actually do to your real diagram on an AP exam. I just put that there as an example to show you. So please don't ever show components on your diagram. Okay, so this component right here. Now, I'm not going to explain the geometry of this because it would take a long time. But basically what we have here is this angle here, which is the same angle as our ramp. And if I'm going to figure out what the leg of that triangle is, it is a sine component. Okay, so it's the sine component of the hypotenuse, or of that angle. Okay, so here's the statement I'm going to put. This is downhill. It's going to be going against the flow. So I'm going to call this one negative Fg1 times the sine of theta. Okay, that's the components wanting to pull it downhill. That's also got friction wanting to, well, not pull it downhill, but friction is a negative force because it's going against the flow. All right, and then I've got good old FT1 wanting to be my lone positive on that one. Okay. Number 2, same thing. It's going to have its own little gravity component just like that other one did. Okay, Fg2 sine theta. Keep in mind the theta in this case is the theta of your ramp. Okay, it's also got friction wanting to pull it downhill. Okay, and then we get our tension. plus ft2. Now, what did I forget? I forgot force of tension 1. That is also on there. So I need to go ahead and put that on there. And why I went on there? Because I want that to cancel once it's all said and done. Okay? We don't want any tensions hanging around. They're bad news. Okay? They make things a little too tense. Okay. All right. Number three. Okay, number 3, we've got our lone positive FG3 minus FT2. So now we can cancel out the FT2. All right. Now, here we go. Putting it all together. Sum of the forces equals... forget that. I'm going to go ahead and do the algebra. I think you've seen enough of it by now that hopefully you can figure out that if I solve for the acceleration of the system, okay, it's going to look like this. Now, keep in mind, my tensions go away. Good. No more tensions. We don't like you guys. Well, I do, but you may not. Okay, go ahead and get rid of the F's. So here we go. My lone positive force. Basically, this force right here is driving the whole system. M3G. I hope you're big enough. Okay, so mg3 minus, what do I want to do next? Let's go ahead and do force of friction 2. Mu mass 2 times g. And this time we cannot neglect the cosine because we are on that ramp and we have to include it on there. Okay, so m2g is my statement for force normal. Okay, what else do I have on there? Oh man, I didn't leave enough room on my paper. Guess what? I can do this. Okay. Minus, man, I got to keep track of all these. There's so many of these things going on here. That's my force of friction too. I've got that one. Okay. Minus m2g sine of theta. Okay. Man, this is a nasty numerator. Look at that. I can't even fit it on one screen. Oh, my goodness. Minus, okay, check that one off to make sure I got it taken care of. Force of friction 1, so mu m1g cosine theta. Good gravy. Look at this thing. Man, and it's still not done. Golly. What a nightmare. Minus... last but not least, this little guy right there. Oh my goodness. Minus m1g sine of theta. Oh my gravy, look at that. Oh man, that is huge. That's big. Look at that. Whoa, man, it just keeps going on forever. Goodness gracious. I'm probably making you dizzy. I better stop doing that. Okay. Divided by the mass of our system. So here's our mass. 1, 2, 3. Oh, man, it's ugly. It is ugly. It is ugly. There is no two ways about it, but it is what it is. Now, what happens if you have to solve for the angle? Like, for example, you don't know the angle of your ramp. Okay. More than likely, if they're going to do that to you, they're going to make this force set equal to 0. Okay. So this whole expression, any one of them that has a theta involved in them, will also be set equal to 0. Okay? And if that's the case, don't panic, because if this is set equal to 0, force of friction, we can figure that out real easy. If you add these two equations together, anything that has those together, those will cancel out. So basically, you're going to be left with an expression. You can do some trig to solve for that. Now, I'm not going to show that in this video. If you need to know how to do that, come see me. I'll be more than happy to kind of show you how to solve for the angle. But there you go. I mean, that's the acceleration of the system. If you have to solve for tension, we've already done that earlier in the other video. But that's really all there is to it. It's not hard. It's just you got to be real careful. I mean, because it's so easy to make a mistake, especially when you got a big old ginormous equation like that one. Okay. All right. Thanks for tuning in, and see you guys on the flip side. Later.